Hello all, welcome you for the lecture series 2 of control system. So in the previous topic also we have discussed some of the topics in the time response. In this video we are going to discuss about the time domain specifications. As we all know about this time domain specification as a little information, let me explain it in the detailed manner in this video here. So in the second order system, the time domain specifications refers to the performance characteristics of the system response to the unit step input. So we are considering the input signals as a unit step for the second order system. So in this response, we have the x-axis as time and y-axis as c of t, that is the response over here. In this time, we are dividing into we are naming into various time periods that we will explain in these upcoming slides. That will be the important specifications what we are using over the time domain. The first one is TD, that is delay time, which we are mentioning over here. Okay. Delay time, that is the here also you can able to see it. That is once the graph start increasing up to its 0.5 value of this output state. So we can define this delay time, that is the time required for the response to reach half of its final value. That's why it is mentioned as 0.5 value till that time we are defining it as TD, that is the delay time. Next one is the rise time. So this is your rise time, what we have circled in the red one. So after your delay time, till the value reaches to the 100%. So we are representing it as TR, that is the rise time. So it is defined as the time required for the response to rise from 0 to 100% of its final value during the underdamped, and for the overdamped condition 10% to 90% of its final value. So this rise time is from 0 to the 100% for the underdamped condition. So this we can express in terms of TR equal to pi minus theta divided by omega d, where omega d is the damped frequency. Next one is the peak time. So this is the peak value occurring in the curve. So that corresponding time, we are representing it as TP, that is the peak time. It is the time required for the response to reach the first peak of the overshoot. Especially the first peak occur over here, the corresponding time period, we are representing it as TP, that is the peak time. So peak time can be expressed as pi divided by omega t, which can be also be written as pi by omega n into root of 1 minus zeta square, where omega n is the natural frequency and zeta squared is the damping ratio, and which all deals with the second order responses. Next, we are going to deal about the maximum overshoot time. This will be happened here. See, particularly in this maximum overshoot values after your 100% till the peak value, that is the maximum overshoot value. This can be defined as it is the maximum peak value of the response curve measured from the unity value, that is from the 1 to the is a 100% value till the maximum peak value. This can be mathematically expressed as MP, which is equal to, that is maximum overshoot, which is equal to e to the power of minus pi zeta divided by root of 1 minus zeta squared, and the whole thing multiplied with 100. Zeta, which we are representing it as damping ratio over here. And the next one is the settling time. This is the settling time. The curve gets settled for some period and it has some allowable tolerance over here also. So after this, the oscillation will become reduced and it got settling over here. So settling time, which we can define as the time required for the response curve to reach and stay within the range about the final value of size specified by the absolute percentage of the final value. So we have some allowable tolerance over here. So that will be differentiated as 2% criteria or 5% criteria. So which can be again represented in terms of mathematically as Ts equal to 4 by zeta omega n for 2% and Ts, that is settling time, which is equal to 3 by zeta omega n for 5%. Again, all this time will deals with, and also it is related to the damping ratio as well as the natural frequency. So in all the formulas, we are representing in terms of zeta and omega n. This is the time domain specifications for all the values, that is TR, rise time, TP for the peak time, MP for the maximum overshoot, and we have two settling times over here for various allowable tolerance error of 2% as well as 5% values. So I hope you have understand these time domain specifications with various time periods and their expression for this time periods also. Thank you.